geeked to be wearing your Elmo sweatshirt. You run 120.0 meters east. Now, that is a vector, it is a displacement. I'm simply giving it the designation as A to identify it as a vector. I didn't give it a name in the problem, but I'm just giving one random, assigning it a random name. So we have vector B, because I'm running 35.0 meters southwest. Then I'm running 77.0 meters north, and then vector D here, 45.0 meters east. And the question is, what was the total displacement while you were geeked to be wearing your Elmo sweatshirt, which is the resultant vector, the addition of all four of these vectors. All right, so let's just take a look at what the picture looks like. It's always good to draw a vector diagram. We have vector A, which is 120 meters east. Then vector B, which is southwest at approximately 35 meters. Then vector D, which is 45 meters, 77 meters north. And then vector D, which is 45 meters east, looks something like this. We're looking for the resultant vector, which is this piece right here. So vector A, B, C, and D, and our resultant vector. Note that this is not just a bunch of lines, it is actually arrows, which indicate that they are vectors with vector designations A, B, C, and D. It's clearly a vector addition problem. How do we start this vector addition problem, please? Tristan.
Find the lengths of the two segments of vector C.
Vector C?
Is that wrong?
That's not correct. That's okay. Nate?
Find the components of vector B.
Find the components of vector B. You're probably seeing the label wrong. This B is the one. If you'll notice, vectors A, C, and D are all either directly in the X or the Y direction. It's vector B that is neither in the X nor the Y direction. So we need to find the components of vector B. So what we do is we draw vector B. We can figure out B in the X direction and B in the Y direction. We know that angle theta in that diagram, Adam, it is.
Is negative.
Adam, why am I doing this? Why am I going through this problem?
Because people are confused about it.
Right, it's helpful to go through it and it helps people to understand. In order to help students understand it, students need to be paying attention. True? So, we know this theta, Stuart, it is?
It's south, west,
Right, but that means something
and
specific.
it means exactly 45 degrees.
So realize, again, southwest is going to be exactly 45 degrees south of west or 45 degrees west of south. That's what southwest means. Good, we can break this vector into its components. Please do so, Deval.
We had to find it. Sine of theta equals over h.
O stands for
Opposite.
over.
Hypotenuse.
Good, what's opposite the theta?
The vector by.
And the hypotenuse.
The vector b.
Great, so the vector b in the y direction equals b times the sine of theta, where b is 35 meters and the angle is 45 degrees. I need, please, b in the y direction, 35 sine 45.
4.7.
That's probably plenty, 6 spaces. No. So that's in meters, 6 spaces. And we can do the same thing with cosine. Cosine theta equals adjacent over hypotenuse, where the adjacent is the b in the x direction divided by b. Therefore, the vector b in the x direction equals b times a cosine of theta, where b is 35 times a cosine of 45 degrees. B in the x direction. And hopefully you can recognize that because sine and cosine of 45 degrees are the same, that we're going to end up with the same value for each of these 24.7487 meters. Matt?
I just think that the values for B, X, are giving it to B, Y should be negative.
Okay, why should they be negative?
Because we're showing south and west should be negative.
South and west, which are both negative. Sure, so we could put the negatives in right there for B in the Y direction, B in the X direction. What is, yes, George?
Why couldn't we draw it like the dashed lines on the other side of the right triangle, like have it?
The question was, why couldn't I have drawn it like this with B here, B in the Y direction, B in the X direction, and that as stated, correct?
Yes.
Who's got an answer for that one? Matt?
It's exactly the same.
Doesn't matter. I could have drawn it the same way. In this particular case, it would be the same because it's the sine of 45 degrees. If it were any other angle, this would be, I call this one theta 1 and this one theta 2, and they would be complements of one another. And so we would have to make sure that we were using the correct angle. For example, if this were 30 degrees, this one would be 60 degrees. And we would get the same answers, but we would be using a different angle. So now we've broken vector B into its components. What's the next thing we're going to do? Stuart.
Make a table of the change next point.
Okay. We're going to list everything, the x and y components of all of our vectors. We have vector A, vector B, vector C, and vector D. Please give me all of the components, the x and y components of vector, let's just start with vector A. Nick, vector A, the x component of vector A?
120 meters.
120.0 meters. I put meters at the top, so I'm not going to repeat myself. And what's the y component of vector A?
0.
0. It has no y component. Good. Sam, components of vector B?
We got 24.7487 for both of them.
Chaz?
Negative.
Remember, they're both negative because they're both in the negative and negative x and negative y directions. The components of vector C, quick. The x component?
77.0 meters.
Good. And the y component?
I'm not quite sure.
Okay. Help her out. That's fine. Donnie. Donna Hull.
It should be 77 in the y direction.
Okay, and what's the x component of vector C?
The x is 0.
Is 0. It doesn't actually go at all in the x direction, so it's actually the x direction that's 0. What about the x and y components of vector D, Chad?
45.0.
And?
0.
0. There is no y component of vector D. Okay, what do we do now? Now that we've got the everything identified in the x and y directions. Juliet?
We use the equation over on the left that says the vector r equals a plus b.
Okay, how do we use that?
We do the vector rx
Okay, the resultant vector in the x direction is equal to.
equals the vector ax.
Okay, if you look, all we have to do is actually add all of these together, right? Because this is the resultant vector, which is going to be the resultant vector in the x direction plus the resultant vector in the y direction. So rather than, we don't have to list all of them, then we can simply look at the table at this point. So just tell me what all the numbers are.
120.0,
Yep.
negative 24.7487, 0, plus 0, plus 45.0.
Great, so the resultant vector in the x direction equals 2513 meters. Okay. We can do the same thing with the resultant vector in the y direction. Again, we can just read it off of here. It ends up being negative 24.7487 plus 77. 2513. Okay. So we figured out the resultant in the x direction, the resultant in the y direction. If you look at that, it's the resultant in the x direction and the resultant in the y direction. Together, they will make up the resultant vector, which is what we're trying to find. So I just want to put visually on the board what this actually looks like. We have initially vector A, which looks like this, vector A. Then we're adding vector B in the x direction, and then vector D. Then we can add vector B in the y direction, and then vector C. And our resultant vector. So notice that the resultant vector in the x direction is the addition of A, Bx, and D. Gives us this side of the triangle. The resultant vector in the y direction is the addition of By and C. Gives us the resultant in the y direction. So that's the whole reason we go through this piece right here. And notice that no matter how ugly our initial drawing is, I mean, we've got vectors going over the top of one another, the resultant vector goes straight through the middle. It doesn't matter. All you have to do is figure out the x and y components and add all of those individually together, and we can get to our resultant vector diagram here, and we can figure out the resultant vector. Victoria, how are we going to figure out the resultant vector?
Could you use the diagram?
Which is?
A squared plus b squared plus c squared.
Good. What are A, B, and C?
A is 140.
Give me the letters rather than the numbers, please, first.
Resultant in the y vector in the y direction plus resultant vector in the x direction equals the resultant vector.
Good. All of those, of course, squared. So we get the resultant vector is equal to the resultant vector in the y direction squared plus the resultant vector in the x direction squared, the square root of. In the y direction, we had the 52.2513 squared plus in the x direction, the 140.2513, that squared, the square root of. We get the resultant vector.
149.6683.
That's plenty. So with sig figs, we get that the resultant displacement is 1.50 times 10 to the second meters, or 150 meters with 3 sig figs. This is our resultant vector, the displacement when we were geeked to be wearing our Elmo sweatshirt. George.
You have to find the angle.
I agree, we need a direction. What is it in the problem that says you need a direction? I agree with that, but I want to make sure people understand why it is we need a direction. Sam?
It asks for our displacement.
The displacement is a vector which has both magnitude and displacement, or magnitude and direction. So please make sure you identify that. Because it asks for displacement, we need the vector answer, which is both the magnitude and the direction. Please figure out the direction for me. Hoover?
You can do sine theta, which is opposite over time.
What is opposite theta?
In the y direction.
I'm blanking on the R. What's the R, your Chishan?
Result.
Or Hoover? Result in the y direction divided by the hypotenuse?
There's I'm blanking.
Bless you.
Resultant
The
vector.
resultant vector. Therefore, we can solve for theta. It's going to be equal to the inverse sine of the resultant vector in the y direction divided by the resultant vector. So we have in theta is going to be equal to the inverse sine of resultant vector in the y direction, which was the 52.2513 divided by the resultant vector. We got to be 149.6683. Theta equals
20.4331.
That's plenty. We're just rounding to
Yeah.
3 sig figs anyway. So we now have 20.4 degrees. And if we draw our little compass rose here, we have north, south, east, and west. That makes this angle right here north of east. That is a very good problem to show component vector addition. George.
Could you have been 69.6 degrees east of north?
That would be the exact same thing. Notice that those are complementary angles, so yes. You could also have said at 69.6 degrees east of north.